What we're simulating here is any type of modality. This is an imaging machine, whatever it would be inside your hospital or your clinic. And so we're using just some simple technology to illustrate that. But everything that's occurring here is being driven by this machine, which is simulated by this laptop. So this could be your MRI, this could be your CAT scan, it could be whatever the equipment is. And what I'm showing up above is this heartbeat type monitor, an image of the actual patient, and an image of the operating room, which is us up here in the window itself. So all that is being transferred across the network, across the HyperSpace network, and it's being controlled over here on this side by a remote operator. So this is where your remote radiologist would be. You would have their screen, they would be in their office or their home, wherever would be the case. And what we're able to do is, you look in here, you see that this is implementing our network. It's showing that the core of the network is up and running. It's showing that we have a connection. It's what's called a peer-to-peer connection. But most importantly, it's showing these packets going back and forth. Every single one of those packets is encrypted uniquely with its own encryption key. This is a security level that no one else has in industry, and it's what makes this communication of the images ultra secure. So the remote capability of this is, I'm going to control that system over there. You can see everything that was on that monitor is over here. I can see what's happening in the operating room. I can see what's happening with the patient. And I'm going to have my technician have position the patient. Would you, technician, go put a card on top of the patient over there, and that way it's available? Okay. All right, you see that that's a live image. I'm gonna now come over here and take a picture. I'm operating the equipment. I come to here. See, this is the image. I click it, it does 3, 2, 1. Takes the image of the patient. The image shows up. I can now export that image. And when I export this image, it's actually exporting it. I'll call it Tuesday 3, since it's Tuesday. It's early in our show. So what you have is that image is now stored over on the system, the PAC systems over there, or the radiology information system over there. But I also have access to it over here. You can see Tuesday 3 is over here on this system. That system that's over there, the radiology system, is mounted to the remote site. So I can see everything that I need to see.
So this reflects what they're seeing.
It reflects what they're seeing on the other end. And if I take that picture I just took, and I bring it to my local desktop, I want to have more close analysis of it. I can bring that picture up, and you can see that this is the picture that was over there, and you can do your analysis. So you have access to the remote system, and it's a secure access and a high performance access. In fact, this is something that if you are someone who goes to different locations, you may find yourself behind different firewalls. Different hospitals and different clinics have different firewalls, or different locations. If you're traveling, even like hotels, this convention center, we have a different firewall. You can get around those firewalls and access the device you're trying to utilize and operate or see images from without any hindrance. We don't have the same barriers that other people have with firewalls. So this is a simple example of what we do, but again, it's securing the transport of the images wherever you are as a remote.
Now, could I ask a question?
Yeah.
All right, so you're encrypting each data packet. And it takes a certain amount of time to make that happen. How do you not lose time in transmitting a whole bunch of data packets?
Well, we have a protocol that allows for the encryption to be able to stuff packets together inside the transport in such a way that the communication is very, very efficient. We also have the encryption occurring on each of the devices. So it's a very minimal load in order to be able to do that encryption. We don't have one system that has to have a supercomputer in it to be able to handle all the encryption for all the devices. We distribute that out so that every single remote device and every single server does a little bit of the work. Therefore, the amount of work that has to be done is minimal.
And how big a file can you transfer?
It can transfer petabyte files. I mean, really? Huge files that would literally take days to transfer at the highest speed you have. But for most of the imaging you have here, even with MRIs, which are putting out megabytes of images and thousands of them, it's able to handle that transport very smoothly.
And tell me about, obviously the big concern we have is hacking.
Right.
How does this protect you against hacking?
Well, you notice that we have one device here, which is the remote user, and one device there, which is the equipment or the PAC server that we're trying to access. When we have a network connection, it comes up and is only established during the time that you need the connection. If you close down your connection, it's no longer there. So there's nothing that's left open to be able to be hacked into. In addition, it's point to point. So what that means is instead of going to a system that has access to every other node on the network, it only has access to that one other device. So at any point in time, there's only two devices that are communicating to each other. And because we're encrypting on every single packet, there's only a moment in time that a single packet could possibly be hacked. If it's that packet that's hacked, the entire message is still not broken because of the nature of the key changing on every single packet.
So you talked about this.
Yes.
And I'm not sure how this is not hackable.
Oh, this is not hackable? This is not
I'm
hackable.
not sorry.
The network itself?
The network itself, yeah.
So the network itself is made up of devices that are, we have two different types of network devices. One is that the network is only between the end of the device and the two end devices. So it's only a network for a moment in time between those two devices. It's point to point between them. And then if there is a problem with the communication of your current transport system, your current internet basically, we do have an alternative core network that we can switch communications through. And that communication is, again, highly encrypted. So there's only way to have access to those devices if you have HyperSpace and you have the encryption key for those devices at that point in time. So it's not like an internet where everybody has the IP addresses. It is a non-IP address protocol that is routable for us, non-routable for anyone else, and that we can transfer the information. No one else has that access to it.
And it doesn't have to go through the cloud.
It doesn't have to go through the cloud. It goes through the cloud as if it goes through the internet, if that's what you're using, or if you have an intranet, it goes through the intranet if that's what you're using, but it doesn't have to store it there. Almost all the solutions today store something in the cloud and then pull it back down, and while it's in the cloud, it's usually unencrypted and it's sitting there and it's vulnerable. We eliminate that vulnerability by going point to point. So the information is transferred directly from the person who has it to the person who wants to access it and back again. It's not stored in the cloud.
And so do I need any hardware to make this system work?
This runs on all the software and hardware that you currently have. So Linux and Mac OS and Windows OS, all the standard operating systems it runs on. And there are abilities to be able to use this even on your iPhone and Android phone as well.
And this complies with current safety or security standards?
It is. It's all NIST standard compliant, which is National Institute of Standards and Technology. So all of our encryption is NIST standard encryption, and it's also FIPS 140 compliant.
Great.
There you go.